Welcome to Developer Stories on the Road to MSIX, a podcast for developers that are interested in updating their installers to MSIX. I'm Tim Mangan. In Chapter 5, we looked at file type association, shell integration, verb commands in traditional applications and introduced how to determine if you could use the simple solution in MSIX or if a more complicated solution was needed. And in Chapter 6, I showed you how to create the MSIX package for the simple case when using Visual Studio. In this chapter, we'll take a look at the more complicated FTA setups that require a complex solution using the package support framework. But first, a quick review. Traditional applications register file type association, shell integration, verb commands in a registry like this. And last time we had an app that would traditionally use the registry, as you see on the left, and we transformed it into an MSIX package with an AppX manifest entries like you see on the right. But today's application doesn't map correctly into the AppX manifest due to the uniqueness rules imposed by the schema. So how do we handle this? Here we have Visual Studio 2026 with our solution open from last time. We have a couple of traditional applications, .NET Framework-based projects, and a Windows application project that we created last time to handle just one of the two application projects using the simple method. Today, we want to create a new web project that will create an MSIX package with both applications and their file type association, shell integration, verb commands. The limitation in the schema comes from the hierarchy that starts with the target application exe, which then has the file type and the verbs underneath that. But because there's a uniqueness rule on file types, there's no way to have two different verbs with the same file type pointing to different executables. So we have two apps, one of which houses the new edit functionality for the file type, and we just can't handle this the traditional way. So we'll end up adding a component of the Package Support Framework, or PSF for short, that was built specifically to solve this problem. In essence, we add a helper executable named PSF FTA Com to the package and give it its own application entry in the AppX manifest. We also mark that application entry so that it'll not add itself to the Start menu. We then consolidate all of the FTA extensions under this helper app and encode the path to each target executable into the parameters of the verb. When the user selects this verb via right-click, PSF FTA Com will pull the path to the exe out and then start up that exe using the remaining set of parameters from the parameters field. This eliminates the artificial conflict imposed by the schema validation. We can also use this helper when we have a similar type of conflict with COM, especially with COM FTA shell extensions, but that's a lesson for another day. Back here in Visual Studio, let's create our new Windows application project. I'll call this Test WPF FTA Demo 2. In the WAP project, add in both applications as dependencies. And now we can edit the package.appx manifest for the initial basic editing. I'll start by replacing the package identity. That's the name here. And then in the publisher field, I'll put in the subject from my code signing certificate. Like last time, I'll remove the universal dependency that we don't need. And I'll change the entry point of the application to the windows.fulltrust application. Now, our manifest is going to need 3 application elements, one for each of the 2 applications with which we're going to have shortcuts to, and a third for our FTA launcher. So I'll just copy the existing application record and paste it twice. Now let's edit the first one to make a traditional MSIX application for test WFTA1. We'll want to replace the ID, executable, and display name of each application to make them unique. Because we have more than one application package brought in, we must replace the variable for the executable to the path to our exe. The value for that executable needs to be a path relative to the root folder of our package. Now, by default, the exe will be placed into a subfolder using the project name of that app underneath the root of the package. Now, I'll show you later in the ingredients, once they're cached, where that actually is in case you make a mistake and need to see the exact path. But we have to wait until we've built the WAP project to do that. So for now, I'll just put in what I know the path is going to be. Now we do the same for the second application element. Before editing the third element, we need to bring the PSF FTA component and its friends into the package. So let's go find what we need. We can find PSF FTA in the fork of the package support framework that I host here on GitHub. The Microsoft sources don't have this component. All of this is under an MIT license, so you're free to use them. Now, I get asked why there isn't a NuGet for this, and the reason for that is that you wouldn't really like this as a NuGet package. You only want to add a small part of this into your package. So here, if we go to the releases, we'll take the latest release, and you can find a zip file that has the components, which is pretty much what your NuGet package would end up being. So I download it. Now I'll crack it open, and we have both release and debug builds here. We're going to want the release build, so let me open that up. And we only need 2 files from this package to solve our FTA problem. The PSF components come in both 32 and 64-bit flavors, so we'll pick the one that matches your application. In our case, that's going to be 64. We'll need both the PSF FTA executable and the PSF runtime DLL that matches the architecture that we need. So I'm going to extract those 2 files out of this, and then I'll place them in the root folder of our WAP project. Back in our Visual Studio project, we can now add those two files into the project. And just to show you this, let me open up the project file here, and you can see that these are added as content and put directly into what will be the root folder of the application package. The addition of the PSF also requires us to add a config.json file to the root folder of the package. As the only need for PSF in our particular package here is for this FTA, I can use a pretty much boilerplate kind of config.json file that I've already created. So let me bring that in, and we'll take a look at what's in there. So in here, you see that we have 3 applications, and that's going to match the applications that are in our AppX manifest file. And in fact, this ID field here has to directly match the ID field of the application record. So let's go take a look at that over here. And oh my goodness, I realized that I forgot to edit that for PSF FTA Com. So let me fix that up here in the AppX manifest file. Okay, so I do need to change the executable for the application here. And since PSF FTA Com is directly in the root folder of the start menu, I'll just put PSF FTA Com 64.exe right in here. Now, I also have one other change I want to make to this application. I do not want PSF FTA Com to show up in the start menu. So to keep that from happening, I locate the visual elements child and I add an extra parameter to it called applist entry equals none, where none is in lowercase. And it can go anywhere in the element, but I usually add it at the end of the element. Now we're ready to add the file type association in. We'll start by adding the extensions holder element to the PSF FTA Com application. Now we start adding the extension. Oh, wait. First, let's take care of the additional namespaces that we'll need at the top. Like in the last chapter, I copied the UAP definition, and then I make 2 copies of them, one for UAP2 and UAP3. And now I'll fix up the namespace and the reference at the end. And of course, take care of the ignorable namespaces. Back down in our application element, the one for PSF FTA Com, is where we now want to add the extensions for our 3 FTA shell integration verb commands. As a twist, I'm going to set up the FTAs to be different for the 2 file types. .fict1 will just have the open and play verbs pointing to app1, but fict2 will add in the new edit verb for the second application. Now this means that I'll use 2 separate extensions within our extensions element. All right, so here's the first extension, the UAP3 extension with the category Windows.File Type Association. Under that, we'll add UAP File Type Association and add in a name. Under there, UAP Supported File Types. And under that UAP file type, I'll just add in this FICT1 extension this time. Also, under that file type association, we add the UAP2 supported verbs. Now, for this, I want to add two verbs to be defined, and we'll use the UAP3 verb element to do that. Starting with open, we want open to run against application number 1. The syntax of the parameter field needs to be the relative path to this executable placed in quotes, followed by any command line arguments to be passed through that program. As we are already putting this into a set of quotes for that parameter field, we'll need to do inner quotes like you would do with HTML. But we have another issue to take care of. The default working directory of PSF FTA ComProcess will not be the directory that it's located in, but the System32 folder. While there's a way to change that, we can use the special pseudo variable that PSF FTA coms to support this. It's called %msix package root %. And this is going to be mapped by PSF FTA com to mean the root folder of the installed package. Now here, we'll need to double up on those % characters to keep the general verb processing, which is on the lookout for things like %1, from messing things up. So the syntax will end up looking like you end up seeing here. Now we add the arguments that'll be passed to that executable. Play is done the same way. I'll just copy paste and do some editing here. And that completes the first extension. The second extension is similar, so I'll copy, paste, and edit. Edit the file type here. Make a copy for the third verb. change the ID. Now edit needs to talk to the second program. And finish off. Yeah, like this. I think this looks right. Let's save and build. All right, so let's take a look. Oh, yeah. All right, I forgot to put in the folders for the executable. So let me fix that up on all of these. All right, let's look again because I have a negative feeling I've forgotten something. Yeah, but we'll go ahead and build. Oh, cool, an error. Well, I said at the outset of this series that I didn't like the click, 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 voila videos that we typically see. So I guess I've been successful. All right. I seem to have an validation error on the XML. Something's defined twice that needs to be unique. All right, so the error provides line numbers 55 and 44, but those are probably in the actual apps manifest file, not our template. So we'll have to treat that as approximate, but 55, 44, they're about 11 lines apart. All right, so go look at that. Ah, yeah, okay. So I missed changing the .fict to .fict2 in the UAP file type. So go ahead and patch that up. And, well, let's just try to build again and see if I get lucky this time. All right, it looks like I did that okay. Oh, I said once that we had a build, I'd show you how to find the ingredients so you could match up the paths that the project outputs were placed into the package. So if we go to the solution folder, we pick bin, then our architecture, release, and you can then follow the sub-project folders to find the exe. So whatever path we see off of release here is where those files would be in the final package. So let's publish to create the MSIX package. As for last time, this is for sideloading, and I don't want the app installer updates. I'll select my code signing certificate. And I'll add in the timestamping. I don't need the bundle either. Now, publishing is quite a silly name for this feature. There's really nothing being published. It's just being created for publishing. Okay, so we have a package, so let's install it and we'll test. We find the MSIX package under our project folder. And there's a new folder called App Packages, and under here, and it's the file at the bottom. But first I want to make sure that I remove the package from the last video since we're targeting the same fictitious file types. So we'll go to PowerShell, and I'll use get-msix package. I'll put that in parentheses, .name to get just the names of all of the installed packages. Oh, I have both demo 1 and demo 2 and a pretest that I created installed here first. So let's get those removed. Remove the first. And now the second. All right, now we're ready to test. So I'll install. Remove the auto launch. Now that it's installed, let's go find those test files. These are the same ones we used in the previous video. Let's try it. It worked. Using the shift right click, we should see both open and play on Fict1. And yeah, on Fict2, okay, so we also see edit. Let's test open. All right. Now let's try edit. And there it is. If I make both, visible, then you can see the difference in the background color and the title bar, and you can confirm that they're both running in the different apps. So this is how we solve the more complicated combinations of file type associations under MSIX. Previously, I pointed out the GitHub repository where you can find the PSF, but here is the code repository for the test projects that I use for chapters 6 and 7. This concludes this chapter of The Road to MSIX. If you missed earlier chapters, you can get them from the Tmergent LinkedIn page or our YouTube channel. Keep an eye out for new chapters too. You can see some of the ones that we're planning here. But I'd also love to do a podcast with you about your experiences in creating MSIX packages. Just contact me on LinkedIn. I'm Tim Mangan on The Road to MSIX. Thanks for listening.